Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this June 2025 lecture series, we are going to discuss about BJT in electronic devices and applications. Shall we start? Okay, first of all, what do you mean by BJT? BJT is a bipolar junction transistor. It has three terminals, and BJT is a three-terminal semiconductor device. It consists of two junctions. One is P, another one is N, and which are having a capable to amplify or magnify a signal. We know that. What do you mean by amplitude? What do you mean by magnitude? Amplitude, it has only positive side. Magnitude will take both positive as well as negative. Actually, bipolar junction transistor is a current control device and it has three terminals. The terminals are emitter, base and collector. First thing, what is an emitter? In this bipolar junction transistor, emitter, it supplies charge carriers and it is highly doped when compared to base and collector. And in this emitter, which is highly doped, so that it can inject a large number of charge carriers into the base. Emitter is always greater than base. Our next terminal is base. Base is a middle layer in BJT and which is thin when compared to emitter and collector, and basically base is very lightly doped. And third one is collector. It collects charge carriers. Name itself says it is a collector. It collects charge carriers, and this collector is doped between emitter and base, means moderately doped. Emitter is always highly doped because it should inject a large number of charge carriers into the base, and our collector is moderately doped and base is very lightly doped, but collector is always greater than emitter and base in size. While coming into doping, emitter is highly doped, base is lightly doped, collector is moderately doped, but the size of collector is greater than base and emitter. See the diagram. See the diagram. In this diagram, we have a bipolar junction transistor. First one is a typical bipolar junction transistor, and we have two types. One is PNP, another one is NPN. See the symbol. In PNP, the arrow is inside, and NPN, the arrow is outside. PNP BJT and NPN BJT, it has two types. See, in BJT types, we have NPN and PNP. Here, in this NPN transistor, a single P-type semiconductor layer is sandwiched between two N-type because it is NPN. Whereas in PNP, a single N-type semiconductor is sandwiched between two P-type, PNP. See the diagram. Emitter, base, collector, we have only one N, two P's. The two P-type semiconductor act as emitter and collector respectively, while N-type is act as a base. See the second one. Here, two P-type semiconductor act as emitter and collector. N-type is act as base. See here. See this diagram. First one is NPN transistor and its symbol. It has same three terminals, base, collector and emitter. Same for PNP. We have base, collector, emitter, and see the arrow is outside for NPN, that is your output, emitter out, and where in PNP it is inside. See, next one is BJT construction. Here we have two types, emitter base, collector base junction. In emitter base junction, it is formed between emitter and base. During normal operation, this junction is forward biased. In collector base junction, name itself, it gives the junction is formed between emitter and base, and during normal operation, this junction is reverse biased. See here, emitter base junction is during normal operation forward biased, and collector base junction is during normal bias reverse biased. During normal condition, whether it is forward or reverse biased, which is very essential for our basic circuits. See the diagram. We have emitter, collector and metal contact. See here in this diagram we have emitter base junction, emitter and base junction, and we have collector base junction. We have a metal contact for N and P type. During normal operation, emitter base junction, it follows forward biasing, whereas collector base junction follows a reverse biasing. Based on the applications, we can choose either forward or reverse bias. See here, BJT operating modes. In this we have active region, saturation region and cutoff region. What do you mean by active region? The region in which the transistors operate as an amplifier. Saturation region, the region in which the transistor is fully on and operates as a switch such that collector current is equal to the saturation current. See here. And another one region, we have cutoff region. Here in this cutoff region, the excess current or voltage flow is cut off by the component. See here in this modes of operation we have active, cutoff and saturation, and emitter base junction at always forward in active mode and reverse in cutoff and saturation in forward, and collector base junction active in reverse, cutoff in reverse and saturation at is forward biasing. See the diagram. Here we have active region, saturation region and cutoff region. This graph is plot between the voltage and current characteristics of BJT. See the BJT configuration. Emitter base collector. Here we have common base configuration, common emitter and common collector configuration. See in common base, the base is common, and emitter, here we have common emitter and same as we have common collector configuration. Based on the applications and based on the electrical needs and electronic needs, we can identify common base, common emitter or common collector based on our applications and user needs. Thank you all.